What I am going to ask you guys is let's work through this step by step. And I'm going to say, I'm going to do this in a weird way that I think very few of you have done. Why? Because I can. Okay? Not actually that, it's more that I would like you guys to, again, start thinking past just what you even read in my book. Because if I look at this question, it says, the graph of h of x equal to negative x to the 3 plus ax squared plus bx is shown below. Okay. They tell you that a negative 1, 3, 5 and b 2, 10 are the turning points of h. The graph passes through the origin and further cuts the x-axis at C and D. Okay. Ladies and gents, I'm going to do some magic. I am going to solve A and B by using one coordinate. Now, some of you might go and say to me, sir, that's impossible. Just like a magic trick, it's impossible. Okay, but I'll show you guys what I mean by that. Because I have seen it in the past, especially my previous, or my HOD at my previous school. If you guys think that my tests, what I tell you about my tests are impossible, her tests always felt impossible because she stretched you until you felt like you want to break. So what I'm going to do is I'm going to solve the A and B by using one coordinate. Why can I do that? Because I not only know that it lies on h of x, I also know it is a turning point. I know two things. So I'm going to solve this by looking only at this coordinate. Okay? So first of all, I must go and I'm thinking, I need A and B. So my first train of thought is go towards x-intercepts. But I don't have x-intercepts. So my second train of thought is go to derivatives. So I'm going to go and say, but I know that h accent of negative 1 is equal to 0 because it is a stationary point. Everyone's all right with that? Okay? So in other words, if I look at h accent of x, it's negative 3x squared plus 2ax plus b. If I substitute negative 1 in there, it's going to be negative 3 times negative 1 squared, 2a times negative 1 plus b, and that must be 0. So here I have one equation. So I can say this is negative 3 minus 2a plus b is 0 is going to be my first equation. Everyone's all right with me? But also secondly, I know that h of negative 1 is negative 3, 5 because it does actually lie on the graph. So in other words, I'm going to have negative 3, 5 is equal to negative 1 cubed, so I'm subbing it into the original, plus a times negative 1 squared plus b times negative 1. So this is going to give me negative 3, 5. This is 1 plus a minus b, and there, ladies and gents, I have my second equation by only using one coordinate, because I know it is a turning point as well. So sometimes it might feel that it's not enough info, sir. But if it is a turning point, I've got to remember the derivative must be 0 at that specific point. Now I can go and solve this in a number of ways, getting b or a alone, etc., leaving me with a equal to 3 over 2 and b equal to 6. Now, ladies and gents, I'm going to say something that you guys are not going to like, and that's also fine. One of the biggest issues you guys have is you don't know when to stop. Because quite a few of you have spent in excess of 10 minutes on a sum that's not worth more than 5 or 6 marks. Okay? And don't feel guilty. Face the reality that sometimes you guys don't know when to move on. Okay? And now I'm not talking about relationships, please. I'm seeing a few giggles here. Okay? Some of you also there don't know when to move on, but that's a different topic. Okay? But ladies and gents, on Friday morning, as part of our last session, I'm going to take about half an hour with you guys on exam techniques. In other words, how do I prepare properly? How do I write an exam properly? How do I make sure I finish my exams? I'm going to take half an hour to work on that. So please don't get stressed if you didn't finish this at all, okay? Or if you were that person that spent the whole 14 minutes on one sum. Okay, we'll get there. We'll get there. Okay. Now, ladies and gents, let's go on to the second question. Now, determine the average gradient. The moment I hear the word average gradient, I think of delta y over delta x. I don't go towards derivatives because derivatives are instantaneous. They're not average. So I'm not going to do that one, guys, with all due respect. Okay? It's simply the gradient formula for number 2. If I look at number 3, determine the equation of the tangent. Now again, guys, go for the monkey behind the mountain. That's going to help you if you struggle with this stuff. What is a tangent? It is a line that touches a graph. Okay? So I know it's a straight line, so I've got y equal mx plus c. So my two problems are going to be determining m and determining c. So if I look at m, there are 5 ways of determining a value for m. 2 points, parallel lines, perpendicular lines, inclination angle, differentiation. Some of you might have forgotten 1 or 2 of those, and you realize you've got a bit of studying left. Okay? So I'm going to go towards derivative. So I'm going to go towards h accent of x because it is a tangent. And I need c, so I'm going to need a coordinate on that graph. So if I look at this, h to x plus 6, no, I'm lying, that's just 3. So h accent, and I'm looking for it at -2. So this is going to give me -3 times -2 squared, 3 times negative 2 plus 6. So this gives me negative 12 plus 6 is negative 6 minus, so this again is minus 12. And that is my gradient. Okay, I'm glad to see some high fives and not some sucker punches. Okay. So I'm just going to move that a bit like that. But now, ladies and gents, I'm sitting with another issue. I don't have a coordinate. I only have an x value. How am I going to get a y value at that point? What do you say? You, yes. If I've got an x value, how do I get a corresponding y value? You substitute that point in. I am talking now to everyone. Guys, some of you are a bit trigger happy. How do I get y value? Make x 0. No. I'm not saying y-intercept. I'm saying y value. If I've got an x value, I sub it in to which equation? H of x. Not the derivative, because the derivative doesn't give me x value or y values. So I need h of negative 2. Now what is h of negative 2? If I sub this back in, negative 2 cubed plus 3 over 2 to negative 2 squared plus 6 times negative 2. And what is this answer? Say again. 2 seems to be right. This is 8 plus 6. So it's 8 plus 6 is 14 minus 12. Yes, it's 2. So it's 2 comma 2. Okay? Negative 2 comma 2. So I've got y equal to negative 12x plus c. So this is going to give me, if I sub this in, it's going to give me 2 equal to negative 12 times negative 2 plus c. So this is going to give me positive 24. So this is minus 22 for c. So therefore, y is equal to negative 12x minus 22. Okay. Everyone all right with that question? Very typical Department of Education exam question, this one. Now, ladies and gents, I would like you guys to do for me question 4 without derivatives. There you guys are like, whoa, sir. Calm down. Okay. Ladies and gents, I want everyone to stop for me, whatever you are doing now, and I want you to have your eyes in the front, because what I'm going to do in the next 5 minutes, is going to be crucial for your understanding of differentiation. Because what I'm going to do is I'm going to look at question 4 by drawing the original, the derivative, and the second order derivative. I'm going to draw those sketches, and you've got to be able to do the same. Because they absolutely love to ask you this. They love to give you one of the 3 and ask you the other ones. Okay. So let's quickly draw. I'm going to draw f of x on this board. So if I look at f of x, it looks like this. and that, okay. So now my question is, okay, so it has a turning point here at -1, -3, 5, and at 2, 10. The question is, how does the derivative look? It's going to be a parabola, you're right. Who can quickly tell me why without thinking too deep? Guys? Well, the derivative is a parabola. It's an x squared. So I know it's going to be a parabola, either smiling or sad. We'll look at that now. So what am I going to do? I'm going to basically divide this part up into your turning points. Here, this is crucial that you understand it. The graph is going down. So therefore, the derivative is less than 0 because the graph of f is decreasing. So, here, f accent of x, or fx, is increasing. Do you all agree with me? Hopefully. So f accent of x is greater than 0. And here, f accent x is smaller than 0 because fx is decreasing. But what happens at those 2 points? They are where f accent x is equal to 0. Do you guys all agree with me? Okay. So if I have to draw this, f accent x is 0 at -1 and at 2. My derivative is less than 0 here. So it's below here. And as well there. So I know my graph has to be something like that. Okay, well, let's not do that. And in between these, it's going to be positive. And there I have my derivative. It's a parabola because if I derive a cubic, I get a parabola. I get a square. Now the question that I want to ask you guys, oh, this is not drawn to scale, I humbly apologize. What is that point at the top of my quadratic equation? That is the stationary point of this graph. Do you guys agree with me? How would I get the stationary point of any graph? Make the derivative equal to 0. So if I take f accent of x and I derive it again, what am I going to get? The second order derivative. Do you guys agree with me? So if I make this equal to 0, oh, but sir, this is my point of inflection. So this point at the top of my derivative is going to be my point of inflection. Ladies and gents, ignore, listen carefully, what graph it is. It's a quadratic, right? If I've got the two x-intercepts, how do I get the turning point? If I've got the x-intercepts, how do I get the turning point? I just get the point exactly in the middle of this. So, -1 plus 2 over 2. So this is going to give me a half. So at x equal to a half is going to be my turning point of my derivative. But sir, that is going to be my point of inflection. It's always going to be exactly halfway between my two turning points. So if I have to draw my second order derivative, where's my second order derivative equal to naught? At a half. Now I'm going to make life easy for you by looking at concavity. Okay, well, I'm saying I'm making life easier. I don't know whether it's going to be easier for you guys. Here, my concavity is up. So, the second order derivative must be greater than naught. All the way up to there. And then here, my second order, why am I doing F? It's H. Okay, oh, I named it H, sorry. So F double accent of X is less than naught. So on the left of a half, my concavity is up. On the right of a half, my concavity is down. So this straight line looks roughly like this, and that is my second order derivative.